Wednesday night's homework. The first one we are comparing 8/10 to 5/10. Well, luckily, our bottom numbers are the same here. Denominators are the same. So we just have to compare our top. And 8 is greater than 5. Next one, we are multiplying 7,263 times 27. Let's get a little autofocus here. All right, so we're starting with a 7. 7 times 3 is 21. 7 times 6 is 42, plus 2 is 44. 7 times 2 is 14, plus 4 is 18. 7 times 7 is 49, plus 1 is 50. Remember, this is a 20, not a 2. So we're going to go ahead and put down our 0 for the 20. 2 times 3 is 6. 2 times 6 is 12. 2 times 2 is 4, plus the 1 is 5. And 2 times 7 is 14. Okay, add these up. We have 1, 10, 11, 6. Pieces. And so we have 1/6 of a cake. And I've got to put it in 1/4 pieces. So we're starting with 1/6, or excuse me, we're starting with 6/8. We're cutting it into 1/4. So that means I'm dividing it up, right? So I have 6/8 of my cake, and I'm dividing it into 1/4 pieces. We can slide this up so you can see it. There we go. Okay, so we're going to keep, change, flip. This is how much I have. I have 6/8. Put in 1/4 pieces. All right. Keep our first one. Change it to multiplication. Flip the second one. 6 times 4 is 24. 8 times 1 is 8. How many groups of 8 are in 24? 3. So we'd have 3 1/4 pieces. Your next one is dividing fractions. We're going to again use our keep, change, flip. So we're keeping 1/2, changing division to multiplication, and we are flipping the second fraction. So that is going to be 8 over 4. How many groups of 4 are in 8? 2. Okay, well, 888 divided by 16. I listed our multiples of 16. 16 doesn't go into 8, it's got to go into 88. Cannot go over, so we are going to use, 80. 1, 2, 3, 4, 5 times. So we're going to put 5, subtract our 80. That leaves me an 8. Dragging down this other 8. It's 5 again. Subtract 80. Leaves me 8. The other 8. Again. All right, nothing left to bring down. So we can write it with a remainder 8 because it doesn't give us any specific directions. Or if I would have kept going, this would have been a repeating decimal, so we're not going to keep going. So I could say 555 and 8/16, which would equal, because 8 is half of 16, 555 and 1/2. So look at the multiple ways you could have written this answer. 3 ways there. Okay. Next, we're adding decimals. Remember, feel free to pause the video and take your notes as needed. All right, remember, when we're adding decimals, we have to line our decimals up. So if I have 4.88, that means the decimal in the next one's got to be right here, so that puts my 1 and 6 here. There's an empty spot. So I'm just going to put placeholder there, 0. So 1 and 60/100ths is the same thing as 1 and 6/10ths. They're the same size, so I'm not changing anything. All right, so let's add up. 8 plus 0 is 8. 8 plus 6 is 14. All right, 1, 2, and 4, that's 6. Decimal comes straight down, which is close, because the reasonable answer, this would be 5. This is 2 if I was rounding. 5 plus 2 is 7, and this is close to 7, so it's a reasonable answer. All right, our next one, we're subtracting. We need to stack up our decimals, just like we did on when we're adding. Don't have to do that when we multiply. Do have to do it with addition and subtraction. So 71 and 120 thousandths minus 2 and 359 thousandths. We cannot say 0 minus 9, so there is some regrouping that is going to happen. That gives me a 1, but we can't say 1 minus 5, so again, we have to regroup. 11 minus 5, that's 6. We can't say 0 minus 3, so again, we have to regroup. 10 minus 3 is 7. Can't say 0 minus 2, so again, regroup. 10 minus 2 is 8. 6 minus nothing is 6. The decimal comes straight down. Which is reasonable. 71 minus 2 would be 69. Well, that's close to 69, so that's a reasonable answer. Okay. Next says to use the distributive property for this. So we've talked about distributive property. It's been a while, so let's talk about it some more. For distributive property, we need to find a common factor for 24 and 40, something that goes into both 24 and 40. We need the greatest common factor of 24 and 40. Okay, so factors of 24 are, let's try 24. That's going to be 1, 2, 3, 4, 6, 8, 12, and 24. Slide. 40. It's going to be 1, 2, 4, 5, 8, 10, 20, and 40. So what is the biggest number they have in common? Biggest number it looks like they have in common is going to be this 8. We'll find out because we're going to break this down. We're basically just decomposing these numbers. Okay, so I'm going to rewrite this with my greatest common factor outside the parentheses. Now, we got to figure out, how do you get from 8 to 24? 3. 8 times 3 is 24, so my 3 would go here. And how do I get from 8 to 40? 5. 8 times 5 is 40. You know you've got it down to the lowest possible answers when there's nothing inside the parentheses. They don't have a common factor. Their only common factor is 1. So that would be our answer using the distributive property. Definitely take note of this because it's probably going to be on the test. All right, our last one is the type of word problem. It's talking about Maggie down here. Maggie says that the least common multiple of 8 and 12 is 24. Her friend Glenn says the answer is 4, so who's right? Why? Explain it. Okay, so I just wrote down a few notes here. Least common multiple of 8 and 12, 24 or 4. Why? Well, let's write down some multiples of 8 and 12. So if we counted by 8, or counting by 8, 8, 16, 24, 32, 40. I think I could stop there. And then multiples of 12, 12, 24, 36, 48, 60. I think I can stop there. We're looking for the least common multiple, the smallest number they have in common. So if that's the case, Maggie's right. It is 24. So why? What did Glenn do wrong? Well, what's another thing? Instead of multiples, you could list factors, but I think that's what Glenn might have done. Let's check it out. Let's see. If Glenn did factors of 8, that's 1, 2, 4, and 8. And factors of 12, that's 1, 2, 3, 4, 6, and 12. Well, 4 is the greatest common factor. So Glenn listed, or Glenn gave the greatest common factor. He didn't give the least common multiple. Okay. That's it for Wednesday.